Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So before we start with this session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Great. Thank you for confirming, everyone. So my name is Neeraj Kedia, and I have been working in this IT industry for past 14 years now. So before we get started, let me quickly introduce our Edureka Masterclass community with you all. So this community of masterclasses was started back in 2019. And since then, we have been closing into almost 33,000 members so far. And in these masterclasses, we have been conducting multiple webinars and live events on different topics, including blockchain, IoT, artificial intelligence, big data, PMP, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost and there are no charges involved here. So you can always refer to these. And again, to get notified with the entire schedule that we have planned for the month, we can click on join this group and then we will be notified with the entire schedule so that we can free our schedule accordingly. All right, so here we are going to discuss on Python for machine learning, how exactly it is structured. So we are going to discuss on that part. So in here, we are going to discuss on how we can make use of Python and again, how Python can be used for creating multiple machine learning models in this session. So here we are going to discuss on, first of all, what exactly is Python, why machine learning, the applications of machine learning, the type of machine learning, and then if time allows, then we are going to see a hands-on on top of it as well. So first of all, if we talk about Python, then what exactly Python is? Python is one of the you can say most integral component of any data science strategies. In Python, we have to design. So here in Python, first of all, Python is a high-level language like we had discussed yesterday. So Python is for a high-level language that we can make use of for multiple use cases. For example, Python can be used for web development. Python can be used for the web scraping components. It can be used as a backend system. It can be used as the main tool required for data access, or you can say machine learning models. All right. And here there are multiple advantages of working with Python. So basically, in terms of Python, we are going to have multiple features as in it is simple. That means again, there is no complexity. Python is one of the easiest programming language to work with. It is open source. That means again, there are no licensing fee involved here. And again, it can easily embed other components as well. For example, even the codes of C, Python, C, Java, C++, they can be easily integrated. And then it is, again, it doesn't need any kind of compilation. And then we have multiple inbuilt libraries available in Python that we can make use of. So here we are going to talk about what exactly machine learning is. So if you talk about machine learning itself, the machine learning is what? Machine learning is simply making sure the systems they understand or what exactly are going to be the configurations for any system here. That is what we mean by machine learning, right? So before we can automate the process, any process, we have to make sure that the system understands the data sets, right? And how we can make a system understand about data set by using the data set. So we have to train the system first of all, and then only it can make sense out of the data set that we have given to it, right? And that is what machine learning is. So we can allow the systems to learn by examples in machine learning models. So instead of writing the code, what we do is we simply feed data to the generic algorithm, and the algorithm machine, or we can say machine, builds a logic based on the given data set. All right. Now, there is a huge demand for machine learning in 2021 because of increase in data generation, and here we can have a good improvement because see at the end decisions are required to be made, right? Again, at the end we have to make sure that we allow the team to make a better decision, because again at the end, if we are not going to make a better decision, then our competitors are they are going to do that, right? And that is not going to be good for us. So that is why we have to use machine learning for having a better decision making process, and where we can identify patterns and trends in a given data set so that we can make use of it. And that's the main reason why giants like Amazon, Apple, Google, Facebook, again, they have survived, they have sustained in the market for almost more than 2 decades now, because they have been actively using the data sets to predict the changes in the market and the technologies, and that's how they have simply adapted and they're continuously adapting to the changes. And that is why they have been, they have sustained in the market for more than 2 decades now. All right. And then here we have, now these factors make machine learning necessary in 2021 itself. Now there are multiple machine learning types available, like we have supervised, unsupervised, and then we have reinforcement learning. So these are main three types available here: supervised learning, unsupervised learning, and reinforcement learning. So first of all, if you talk about supervised, then supervised is done by using a labeled data set. Now, so whenever we are using any labeled data set as an input to the system, then that is referred as supervised learning. So let's say we are a teacher, we are our way of teaching is to teach by examples. So that means for every problem in life, you are providing solutions to them. And a real-time use case is the email segregation. Now, whenever we receive any email, right, for example, Gmail, right? So we know that Gmail automatically segregates emails based on wherever they have been arrived from. For example, let's suppose they have let's say we have multiple types. We have promotional, we have social email, we have promotional email, then we have spam folder as well, correct? And then we have primary inbox. So how Gmail automatically segregates the entire files based on these folders? So there are certain labels that we have defined. If now for being a part of promotion inbox, the email should contain multiple words such as buy, discount, offers. If it contains multiple links to, especially to the e-commerce segments here, right? So again, these are recipes for the promotional email. Then we have these, then we have the, we can say the secondary, or we can say the secondary inbox, right? Like we have social as well. So again, if the emails are coming from, like if the emails are like regular updates from the social media platforms, then they are going to be again, I can say sorted as a part of social emails. And again, in terms of spam, so again, if there are multiple links to the website given in the mail, which is simply links to the low score, or we can say spam or fishy websites. If we have multiple images, if we have some attachments that seems fishy, so again, they are recipes for the spam emails, right? Again, then we have primary, if we have been receiving emails from any known contacts, if it contain important words such as the invoices or the alerts, or again, they are seen clean without any kind of, I can say, fishes attachments, and they are going to be recipe for the primary inbox. So again, these all are done by using same example for supervised learning method as a real-time use case. So next we have unsupervised learning. So again, basically here we make use of we can say unlabeled data sets. So for example, a simple example is we have the recommendation engine. In unsupervised, we have simple example as recommendation engine. So for example, if we watch Netflix now, when you're using Netflix or YouTube, we get multiple recommendations. Now they are not based on any labels, right? So for example, whatever videos we are watching here, in which video we are spending more time, what kind of movies we are watching only for some specific, when we are watching some specific parts of the movies or the series, if we are watching the full movie or series or not, right? So there are multiple unlabeled data set that has to be worked on. And these recommendation engines are also examples for unsupervised learning, where we don't use any kind of labeled data set. We allow the system to understand the context of data depending upon how the algorithm has been structured as a part of unsupervised learning method. And then we have reinforcement. So reinforcement is simply the area of machine learning inspired by the feedback mechanism. So again, we define an entire system, and then we let system take up the action on its own. If it takes a good action, then we reward it by a positive pointer. If it doesn't, then we simply penalize them by simply giving them negative pointers as well, correct? And that's how they simply learn, okay, what they have done is right or wrong. So a simple example is the autonomous driving vehicles. We have the NLP engines, right? So again, when we continuously give feedbacks if they have done right. For example, if the autonomous vehicle hits, we can say, a roadblock, so obviously that is going to be a negative pointer for it. And next time, when it actually gets a roadblock, it's simply going to review it. So whether it should simply hit it or simply is to simply divert its entire route, or what exactly needs to be done. So that is going to be analyzed by the system when it gets the same situation again. So it will remember the what was the feedback for its last action, and that last action is, if it was positive, then it is going to be repeated. If it was negatively weighted by us, then it is going to perform a different course of action. and that's how we make sure system simply understand on its own. So based on its own outcome, it is going to understand what it has been done good, what has been done in a wrong manner, and that's how we can allow the system to improvise the accuracy and the accuracy of the actions it is going to perform. That's how it works. All right, so that's how it works in terms of unsupervised, or we can say reinforcement learning. All right. So what is the difference between supervised and reinforcement? Reinforcement unsupervised, we simply give the data set, and in terms of unlabeled data set. But here in reinforcement, we don't train the system directly. We simply allow the system to learn from its own actions, and we simply give a reward for a good, or we can say a good action, and a negative pointer for, we can say, an incorrect course of action that the system may have performed. All right. So that is how we define here. And again, there are multiple types of machine learning problems that we have, and there are multiple tools available for machine learning. Now, here we can talk about why exactly we need to use Python for machine learning. So why Python for machine learning? So it is easier to learn. It has a good support in terms of all the available libraries. And again, here we have, again, first of all, it is all open source, so there's no licensing fee involved here. And it offers easier implementation methods as well. All right, so here we can see a small hands-on in terms of the Python libraries that we can make use of. So here, as a small example here, we can simply make use of any specific library, how we can make use of it. For example, suppose here, we can work with any of the IIDs available. For example, let's do one thing. Let's use our IID as PyCharm. So we can, to work with Python, we can use any IID. We can work with Jupyter Notebook. We can work with PyCharm. We can work with even Python CLI as well. Whatever matches our requirement, we can simply go ahead and make use of it. So when we are working with Python IID, or let's say we have PyCharm. So in Python, first of all, PyCharm is offered as a free tool, so we can go ahead and download it. And here we have two different. Now here to install more libraries, we have to go ahead and click on File, and then we can navigate to Settings. Now, in case we don't have all the packages available, then we have to make sure we do go ahead and download all the packages that we can work with. All right. So for that, we can navigate to the Settings tab, and here we have something called as Project Interpreter. So here we can choose which interpreter we are currently using. If we are using Python 3.8, that is currently running on top of Anaconda framework, we can choose that, or we can use any other version. Suppose if we may have multiple versions of Python installed, like Python 2.7, 3.7, in terms of multiple versions. So we can choose which version we want to make use of, and then we can see the list of all the available libraries in that. For example, as you can see here we have a list of all the available libraries. So in case we feel, okay, some libraries are currently missing that we haven't installed, we can click on add, and again, these all libraries can be installed directly as well. We can also do that. All right. So here we are going to work with NumPy, so we can click on OK. Now here we are going to work with NumPy. So as a part of a small hands-on, we can use NumPy. NumPy is used for calculation. So NumPy is something which stands for numerical Python. It's one of the core library required for scientific computing. So using NumPy, we can work with multiple arrays and number of objects as well. So for example, let's say here we want to work with simple arrays as well. So now, as a simple example, if we want to work on a list, so here we can first of all start by defining import NumPy as NP. So we can abbreviate it at any way we want, and then we can define, suppose if you want to work with time, so we can work on importing time again as a library available in Python. If you want to work on importing the system library, we can define system, and then we can define, suppose here we want to make use of a range of numbers. We can define s as a simple variable, and in here we can define by using a given range. So now we can define what range we want to work with. Suppose here we can define range, suppose as 1000. We can define the range as 1000 itself. And then we can define, suppose here we want to print the statement. So for printing, we have simply a print statement. And here we can define sys dot get size. Here we can define get size of, and then we can define the index value as 5. And then we can define, we want to find the length of the S range that we defined here. All right. And then we can create a new data frame as D, and then we can define, let's suppose we want to make use of same NP library here as NP, and we can define NP range. For example, here we want to arrange the numbers here for a given list for 1000. And then we can define a print statement again. And here we can define, we want to print size multiplied by d dot item size. So for getting each and every item size, we can define that. So NumPy is used because again it occupies less memory as compared to list, and this is we can say pretty fast. Basically here what we had done, we have now here we can execute the entire statement here. So we can right click anywhere, we can click on run file, and this is going to be executed. And as you can see, this is the output that we have received. So basically the above output, now this output shows that the memory allocated by list, which we have denoted by S, right, is again 28,000, whereas the memory allocated by the NumPy array is just 4,000. As you can see here, memory consumed by list is what, 28,000, whereas the memory occupied by NumPy is only 4,000. That's why we can see how much fast it is. And that's why we use NumPy as a preferred option as compared to the list size here. All right. So here, that's why we use NumPy, because again, it occupies much less memory as compared to the original list here. All right. So same way we can also take another example for seeing how faster an NumPy array is as compared to the given list. We can take another example. So for example, let's say here, let's do one thing. Let's add the entire code as a comment. Now we can add a new file. So here we can find import time and sys, and we can see multiple more examples to see how exactly we can work with more operations on working on NumPy, how we can make use of it for presenting the entire report here. So now here we can also define, suppose here we want to import NumPy. So here we can define import NumPy as NP. We can define that. Suppose here we can create a small array. For example, here we define from NumPy dot array. So again, array is like a inbuilt, is already inbuilt in NumPy and here we can define the range, suppose as 1, 2, 3, as elements here as 1, 2, 3 as in different elements as a part of array. And then we can define another array element within this entire array that we have defined here. We can define, for example, let's create multiple elements. We can define 1, 2, 3. Again, we can define, suppose as 4, 5, 6 as the elements. And now suppose here we want to print this, we can simply define from the variable a as we can define the. So basically here we are going to define this as a part of the dimensional array, and this is going to be simply printed as a part of 2, right? And here we can also find the item size as well. For example, we want to find the item size for a single item. We can simply replace this one with item size. We can go ahead and copy this one. And here we can replace this, suppose, with item size. So the item size for the current array is going to be printed as a part of response. So as you can see, the item size has been printed as 4. Now we can find multiple data type. We can find the shape as well. We can also work on reshaping the elements if we want. For example, we may have a multi-dimensional array. For example, we can import NumPy as NP. And here we can define, suppose, a as np.array. And within this, we can define, suppose 8, 9, 10. And here we can add one more element, suppose as 11, 12, 13. And then we can define print. First of all, we want to print the array here, and then we can define a is equal to a dot shape for finding the shape, or we want to reshape it, we can define reshape as well if you want to reshape the same element. All right. Here we can define reshape. Now suppose here we want this to be reshaped to 3, 2. And then we can define print a again. So first of all, we are going to see the older shape. That means the original shape here, and then we are going to see a new shape being defined. So if we run this file here, we are going to see the transformation being done. So now earlier it was supposed 3, 3, and now it has been defined as 3, 2. So the same elements, but again, it now has been converted to a 3x2 matrix. And here we can perform multiple arithmetic operations on top of it as well. For example, let's say here we want to perform arithmetic operations. So now here we define this array here, right? Suppose if we want to create additional array, suppose here we can copy this one. We can define this one as B. So now we have two different arrays. Now if we want, we can define the same element, and now suppose we want to print it. So here we want to print the sum of these two. So we can define A plus B. So now both the matrices, both the array, they are going to be added, and the sum of it is going to be simply returned to us. As you can see here, now we have 8 plus 8, 16, then we have 18, then we have 20, 22, 24, 26. They all have been added here. That's how it works. And we can perform multiple more operations in terms of define the access. If you want to display the output in terms of the spatial functions, then we can use spatial functions as well if you want. For example, here we can define this one as suppose spatial functions. Now for spatial function, we can define, suppose we also have to import matplotlib library as well. So here we can also import matplotlib. Now, if in case you want to work with all graph, we can define matplotlib.pyplot, and here we want to import that as plt. And now we can define, suppose here we can define x as, suppose from the numpy we are going to make use of now a range here, a range, and here we can define suppose 0 and suppose 3, the value of 3 multiplied to suppose np.py value as np.py, and here we can define the value suppose as 0.1. All right, and then we can define, suppose here we can define y is equal to suppose np dot, here we are going to find the sine value for x. We can define sine x, and then from the same plot graph here we can define plt dot plot. We want to plot the graph containing x and y, and then we can define plt dot show. So this is like a inbuilt function available in this matplotlib library that we had defined. So first of all, the array is going to be printed, and a graph is also going to be displayed as well. As you can see here, the same graph has been presented to us. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye bye.